Hello, and welcome back to the second video of the series. If you notice, the organization is actually a little different. I am now using Gradle for my builds. I also moved the window outside of the main, and I have put that into its own window class. But other than that, everything, including the mesh and everything that you have, should technically be the same by this point. So yeah, this video we are going to be implementing shaders. Since the last time we left this, we have our mesh. It's in the graphics card's memory, but some graphics cards requires a shader from the user. And my graphics card happens to be one of them that wants and requires a shader. So let's go ahead and start creating our shader. Within our shader class, we are going to want a few integers here. So basically, we'll need a vertex shader, and we'll need a fragment shader. So let's go ahead and have these in. Okay, so the vertex shader takes all of our vertices and it moves it around in space pretty much. It places each individual vertex on our screen, and it passes these values over to our fragment shader. And our fragment shader gets into the awesome stuff. Our fragment shader basically rasterizes those points and creates a lovely object on screen. We can create solid colors with the fragment shader. We can create textures and basically everything with color. Now, OpenGL, unlike DirectX, doesn't accept two individual shaders. Instead, OpenGL wants shaders combined together into a program. So we'll also need a program. Okay, so off camera, I went ahead and created these key functions here, the four functions below the constructor, and these functions are going to be really important. The create function creates our shader, the destroy function destroys the shader, and the use shader function obviously uses the shader. Well, what about this read source? Does exactly what the method says. It'll read the source file of the shader. So let's actually get started with the read source, so that way we can get this all out of the way. All right, for our source reading method, we're going to need a few objects. The first one being a buffered reader, and the second one being a string builder. So our buffered reader will read our shader, and the string builder will basically put all of what we have received together. You'll see how this works. Now, within the try clause, we're going to initialize our buffered reader. And then this is kind of where there are two ways of doing things. Now, the first way is keeping all your resources outside of the jar file. And in this case, you would use a file input reader. In my case right now, I am actually putting all of my resources inside the jar file. So in this case, we would use a new input stream reader. And then this input stream reader is going to want our resources. We can use this by calling a get resource function, but we don't have access to the function. So what we need to do is we need to use the get class function. And this get class function will allow us to use the get resource as string. Now, the string we want to pass in would be /shaders/ and then we'll add file to the end of this. Now we need to read from our reader. And this is actually quite simple. Essentially, we'll need a string, and this will be reading a line from our buffered reader. And then we'll use a while loop to loop through it all. And essentially, within this while loop too, we can actually set line to the reader, read line, and then we want to test to see if this isn't equal to null. If it isn't equal to null, then we can just add it onto the source builder. So we can go ahead and catch for an IO exception, and then we will add finally, where we will put in one more try and catch clause, and then we will close the reader. Now it's, oh yeah, I forgot. Make sure we set buffered reader to null and our source builder to a new string builder. And after this almighty big mess, we will return source builder to string. So by this point, we are ready to create our shader. Let's go ahead and import the OpenGL functions we will be using. Okay, so the only thing I'm importing from OpenGL 1.1 is GL false, otherwise known as 0. And we're going to be importing every function that we can get from OpenGL 2.0. So let's go ahead and create the Vertex Shader. So we can go ahead and do, or set the Vertex Shader to GL create shader, and then we'll want to pass in GL Vertex Shader. This creates a Vertex Shader for us. Now we're going to want to send in our source file, so we can go ahead and do GL shader source, our Vertex Shader, and we can pass in read source shader plus .vs. Then we're going to want to compile our shader. So these functions are pretty straightforward. And now we have compiled our shader. Sometimes we'll run into problems. Right now we have no way of knowing where. We want to be able to receive this value. We're going to create an integer array at the top here, and we'll just set the size to 1. OpenGL provides a function that basically allows you to get the state of the shader. This function is GL get shader I. And we'll just pass in the Vertex Shader. Wait a minute, this isn't the right function. Wait, does this actually return an integer? Oh my goodness, it does. You know what? Success is no longer going to be an array. No longer is success going to be an array, because I didn't realize LWJGL had this function in place. Cool. So we'll actually use success is equal to GL get shader I, the Vertex Shader, and pname can be a lot of different values because there are a good number of things you can actually get from this function. But what we are more interested in right now is the compile status. Now, according to the documentation for OpenGL, OpenGL will return GL true if the compile was successful. If success is equal to GL false, then we're going to want to print out the problems of our shader. So we'll use the system.error, print line, and we'll want to use GL get shader info log. And we'll pass in the Vertex Shader. Cool. We have created and compiled a Vertex Shader. Now let's do the same for a Fragment Shader. And you can just essentially copy. I am not going to use my mouse. And paste. And we're just going to change all of the vertex to fragments. Don't forget to change the file extension. Okay, we got our two shaders. Now, if this was Direct 3D, we'd be done with it. But OpenGL wants us to combine these together, link them, and then validate them. So the first thing we need to do is create a program. This is where our program variable comes in. Then we want to attach all of our shaders to the program. Using the GL attach shader method, you can tell which shader and which program you want to attach that shader to. All we have to do now is link and validate our program. GL link program and GL validate program both can cause errors, and so we'll essentially need the same thing here. So I'm just going to copy and paste it after link program, and I'm going to change this to get program I. I'm going to change this to program, and we'll change compile status to link status. Then we'll use get program info log, and we'll pass in program. And we can go ahead and copy and paste this again right after validate program, and use validate status instead. Then we can just return true. And then you'll want to return false for when the shader fails. Now we have to destroy our shader, and this is simple as well. The first thing we do is we detach both the shaders from the program, then we delete both the shaders, and then we delete the program. Simple as that. And last but not least, we need a use shader method, and this is just going to call GL use program, and then we'll just pass in our program. Now that our shader is pretty much finished, we need to create the actual shader. This is fairly simple as well. It's basically, the language is GLSL, and it's based off of C. And so I am actually going to create two files, basic.vs, and no thank you, and basic.fs. So right now we need to use a preprocessor, hashtag version. We need to tell the compiler what version our shader is going to be targeting. And we're going to use 330. And we're going to want to create an attribute for this thing. We can use layout, and then we want to set a location for this. So inside parentheses, we'll put in location equals 0. We'll see what this location is in a bit. And then we'll want to use in a vector 3, and we'll call this position. Now we'll want a main method, so we can use void main for our main method. And now we got our main method. Now OpenGL gives us some variables that we can then mess around with, or send data to and receive data from. The Vertex Shader has GL position, and GL position is basically the vertex position on the screen. So we can go ahead and use our position. This would work, but it's not going to work. You may be asking why, and that's because GL position is not a vector 3. It's actually a vector 4. That fourth value helps with clipping. Let's go ahead and cast this into a vector 4 and make sure that last value is set to 1. Our Vertex Shader is now complete. Now let's get on to the Fragment Shader. So we'll have the same thing, a version, and a main method, except this time OpenGL used to provide a function for us to use, but they've gotten rid of that. This is just one extra step. We need an out variable, and so this can be out, and then we'll use a vector 4, and I'll call it frag color for fragment color. Then we can set this color to any value you want. Now our shader is finished. We can go ahead and create our shader. So basically we're creating our new shader, and we're setting it to the name of our basic shader. We are binding the shader before we draw, and then we destroy our shader. Now comes the moment of truth. Let's see if our triangle now renders. And look at that. If we didn't have our error catching system, we wouldn't have caught this error. So over the 20 minutes of looking for this bug, it turns out I forgot to add a new line after the previous line. So essentially we're just building on one line, and that's not good. So make sure you also add a new line in the read source every time you add one onto the source builder. And the second bug is the copy and pasting. It can be hurtful. This was actually Vertex. Make sure that's Fragment. Make sure when you copy and paste, everything is correct, because copy and paste can be your friend, but it could also be your enemy. So let's go ahead and run this. I just built it, so let's go ahead and run this and see if our shader works. And it decided to build again. There we go. There is our triangle. What's cool is that inside the shader, you can actually scale and translate our triangle. try to scale and translate our triangle. And next time we meet, we will be doing just that, but in a more advanced way. I want to apologize for the terrible mic quality. I was playing around with my makeshift filter. Wasn't a good idea, so I apologize for the crappy quality of the microphone. And another thing is, I actually tried to change the style of the video, and basically I would try to, in some places, to basically say that we need to do this certain thing, and then I would type in everything that needed to be typed in off camera, and then afterwards I would say, this is the function we're using, and explain why or how we use the function. And I tried to do that in a lot of places, and some places I just couldn't because it wasn't actively in my head. So it's kind of a mix of what I did before and what I wanted to do for this video. So I would like some feedback on if I should continue doing it this way, improve upon it, or go back to what I was doing before. I will see if I can actually put a poll up for that. I'll see if I could try that. We'll try out that YouTube feature. But anyways, I hope to see you guys in the next video. I believe in the next video for this series, we're doing 3D transformations with matrices and adding a uniform variable to our shader. So I hope to see you guys in that video.